of all, thank you for watching this video. Today I'll be discussing about block diagram. What do you mean by block diagram? It is one of the most important concept which will be used in control system engineering. Let us discuss what do you mean by block diagram. The block diagram is a pictorial representation of a control system which will be explaining cause and effect relationship between the input and output of a physical system. In other words, we can say that practical representation of a control system is its block diagram. It is not always convenient to derive the entire transfer function of a complex control system in a single function. That is true. A complete control system can be represented with a required number of interconnected blocks. So we can say that it is a pictorial representation of a control system which gives the cause and effect relationship between input and output. It is a convenient form to do the analysis. It is better to represent a physical system in terms of block diagram so that we can perform the analysis very easily. That is why we will be using block diagram. Moving on to elements of block diagram, there are 5 basic elements. The first element is known as block or functional block. The second element is branch point. Third one is summing point. And fourth one is takeoff point. And finally arrows. These are the 5 basic elements of block diagram. Let us have a brief discussion individually. Let us discuss the first element, block or functional block. Block is a symbol for the mathematical operation on the input signal to the block that produces the output. In block diagram, all the system variables are linked to each other through a block. You can see this is a block representation. We have input R of S and output C of S. Inside there is a mathematical function G of S. Always there will be a mathematical variable or a function inside the block. Okay, this is regarding block, or you can call functional block. The second element is branch point. What do you mean by branch point? A branch point is a point from which the signal from a block goes concurrently to other blocks or summing point. So this is known as branch point. So the signal is moving towards the particular function G or particular block G, and you will be having the output. But from this point, the signal will be moving to other block or other summing point. You can see this point is generally known as branch point. From this branch point, the signal may be moving towards other block or summing point. So this point is one of the most important terminology related to block diagram, that is known as branch point. Okay. Let me move on. Summing point. What do you mean by summing point? As the name suggests, summing means summation, addition of two or more signal. Summing points are used to add 2 or more signals. So this is one of the typical example of a summing point. There are 2 signals, signal A and signal B. It is having the polarity positive, and here also it is positive. So if you get this kind of summing point, then the conclusion will be A plus B. A will be given over here, B is also given over here. As the symbol concerned, we have to add 2 signals, A plus B. Here if you look at the terminology, the positive is here, negative is here. Then the output will be A minus B. So we can add 3 signals also. Okay, so this is actually basics of summing points. This is one of the most important elements in block diagram. Let us move on. Takeoff point. What do you mean by takeoff point? A point from which signal is taken for the feedback purpose is indicated by takeoff point in block diagram. So basically the feedback path will be taken from the takeoff point. As you can see, this point is known as takeoff point. From this point, feedback will be taken place. Feedback means from the output there will be interconnection towards the input. So this element is known as feedback element, or that particular point is generally known as takeoff point. So this is also one of the most important point which is related to block diagram. Let us discuss about arrows. Arrows are nothing but it gives the direction of a signal. Arrows provides, or arrows indicates the direction of signal. The signal can travel along the direction of arrow. See the signal will be moving towards in the direction of arrow. Okay, so this is the movement of signal. See, we can observe the movement of signal. So that arrow that represents the direction of the signal. How about the movement of that particular signal? So you have to specify the direction. With the help of that particular arrow, you can predict the direction of signal. So that is about arrows. So these are the major 5 elements in block diagram. Now let us represent a physical system into a block diagram. With the help of one simple example of liquid level control system, I can convert the simple liquid level control system into block diagram. Okay, so that we can verify how to convert the physical system into block diagram. In the extreme left side, you can observe my pointer. In the extreme left side, there is a physical system. In your right side, this is actually the block diagram. Okay, now let us discuss how we can convert the physical system into block diagram. Here you can see your tank. See the water tank. See the water tank. Water tank is your system. Your goal is to maintain desired height for the particular water tank. You need to maintain desired water height. Water should be maintained at a desired height in that particular water tank. Okay. Now, to check the desired height, we are having one of the element that is known as float. By using float, we can determine the water level. Okay. Then the float will be directly giving to controller. Float is directly feeding to the controller. So then controller will come to through the controller. It will take a necessary action towards the pneumatic valve. If the water level is reached, if the water level is not there, what is going to happen? The float is going to sense. Float is sensing that float is going to sense that water level is not reached. Then controller is going to act. So based on the controller action, what is going to happen? The pneumatic valve actually getting operated. So based on the operation of pneumatic valve, the water will come inside. Then water is going to fill in the tank and it is going to maintain desired height. Suppose on the opposite hand, if the water level has been reached, suppose the water has been reached in the desired height, then float will come to know that water level has been achieved or water level has been reached, desired water level has been achieved. Then it gives the control signal and it will turn off that particular valve. The valve will not operate. So that water is going to block. This pneumatic valve is going to operate. There are two cases you need to explain. So we can say that the float will act as a feedback element or a sensing element. So this is the controller. Either it may be mechanical controller or electronic based controller, whatever it may be. Then the pneumatic valve is associated with this controller. Okay. Then your water tank. This water tank will act as a system. Your water tank will act as a system and this will be your output. Now let us convert the entire elements in the physical system to the block diagram. First and foremost thing, I need to mark the system. Which is the system? Tank is your system. So I need to prepare a separate block diagram for the tank. So this block has been created. That means tank is your system. Now you have to mention the controller. I need to mention the controller with the pneumatic valve. See, controller and pneumatic valve that has been connected in a separate block, two independent block, controller plus pneumatic valve. However, it has been connected each other. And of course, the float will sense the water level. So we can say that float is a feedback element. The float will act as a feedback element, as you can see here. It will sense the water level. Whether the water has been reached in a desired height or not, that is going to detect with the help of float. So we can say that float is a sensing element, or you can call it a feedback element. So the path will be like this, feedback path. Actual water level will be measured with the help of float position, and you will be always having a desired water level. So actual water level and desired water level will be compared each other, then the error signal will be generated. Based on the error signal, the controller is going to operate. Controller will provide the signal to the pneumatic valve so that the valve is going to operate. Then that water will be maintaining at the desired height in the tank. So this become a closed loop control. This path is known as feedback path, and this point is generally known as takeoff point. And this path is known as forward path. So we can directly convert entire physical system into block diagram. So basically two concepts are similar, but the way of representations are different. If I look at this particular segment, we will understand very easily compared to the physical system. This physical system is simple, but if you go for a complicated physical system, then it is difficult to understand. But in spite of that, if you plot everything in a block diagram, the user will come to know that what is actually happening in the control system. So this is a conversion of physical system to block diagram. Now let us figure out the advantages of block diagram. It is easy to construct. The function of individual element can be visualized from the block diagram. It is very clear. Overall system performance can be studied by calculating the transfer function from the block diagram. And of course, overall transfer function can be calculated by using the block diagram by using block diagram reduction technique. We'll be learning block diagram reduction technique in the part 2 that I'll be explaining thereafter. So these are the advantages. Now let us figure out the drawbacks of block diagram. The block diagram is having the following drawbacks. The first drawback is block diagram doesn't include any information about the physical construction of the system. That is true. System may be either electrical system or mechanical system or pneumatical system, but the block diagram, if you look at the block diagram, we never come to know that what type of system is employed over there. That is the main drawback. Regarding the second drawback, the source of energy is not shown in the block diagram. Where is the energy supply? That is not available. The number of different block diagram can be drawn depending upon the point of view of analysis. It varies, that is true. Depends on the user, the way of analysis will be different. So the block diagram for the given system is not unique. That is another drawback. These are the few drawbacks regarding the block diagram. So now we discussed about what is a block diagram. What are the main elements of block diagram? We have explained 5 individual elements of block diagram. Thereafter, I have explained how to convert the physical system into block diagram, and later I could explain the pros and cons of block diagram. The following textbook I have referred. The first one is Control System by A. Nagurkani, and the second textbook is Control System by U.A. Bakshi and V.U. Bakshi. These are the textbooks which you can also refer. I have collected the information after referring these textbooks. So, if you are having any doubts regarding the topic which I discussed, kindly put up in the comment box. Definitely I will reply back to you. So, thank you for watching this video. Please share and don't forget to subscribe. If you are preparing for any kind of competitive examination, I have one more channel, namely Winners Capsule. You can follow up the same channel. Then you will be getting lot of information regarding various competitive examination. I need your valuable support for the upcoming days. Thank you very much.